Hi guys, today we're going to talk about solving two-step equations, and the I can statement we're working on is I can solve multi-step, real-life, and mathematical problems posed with positive and negative rational numbers, meaning integers, in any form, though. So we're going to extend that to whole numbers, fractions, and decimals using tools strategically, and today the tool we're going to use is actually the order of operations. So let's recall what the order of operations is. First I do parentheses, or anything in a grouping symbol. So that can include, operations inside the absolute value symbols, or operations in the numerator or denominator of a fraction. Exponents, multiplication and division, and then addition and subtraction. And again, multiplication and division we do left to right, same as addition and subtraction, depending on which comes first in the problem. But when we're solving an equation, we need to use the reverse of the order of operations. So I'm first going to undo addition and subtraction, then I'll undo multiplication and division, and then exponents, and then any operations I have within the parentheses or grouping symbols. So let's look at an example. In this problem, I have multiplication and addition. But since I'm solving this equation, I'm going to work backwards. Meaning, instead of taking care of the multiplication first, I need to take care of the addition, and I do that by using the inverse operation, which is subtraction. Then I'm going to need to use the inverse operation of multiplication, which is division. So the first thing I'm going to do is subtract 8 from both sides, and I do that to keep a balance. That leaves me with 2n on the left and 12 on the right. Now I need to divide both sides. So I'm going to divide both sides by 2, which leaves me with n on the left and 6 on the right. But before I can just say 6 is my answer, I do need to check my work. So I do that by substituting my solution into the equation and then using the order of operations, so I have to multiply first, to see if the left side and the right side do in fact have the same values. And 12 plus 8 equals 20, so I know I'm correct, and n equals 6 is my solution. In this equation, I have multiplication and subtraction. This means I'm going to have to add and divide in order to solve. And I'm going to add first because I'm using the opposite of the order of operations. And I'm going to do that to both sides because I have to keep a balance. So 54 plus 12 is 66. Now I divide both sides by 3, and I get m equals 33. And when I go to check my work, 3 times 33 minus 12 equals 54. Let's check it. 3 times 33 is 99. Minus 12, does that equal 54? Nope, it equals 87. That does not equal 54. So I did something wrong, so I need to go back. I'm going to go back and check my work again. So 54 minus 12, that gives me plus 12 gives me 66, so that's good. And 66 divided by 3, oh, that's where I made my mistake. 66 divided by 3 is actually 22. Let's check now. 3 times 22 minus 12 equals 54. 3 times 22 is 66. Minus 12, that does equal 54, so now I know m equals 22 is correct. Okay, in this problem, 1/8 is being multiplied by a, so I do have multiplication, and 40 is being subtracted, so I have subtraction, which means I'm going to need to add and divide. So let's start using the order of operations backwards by undoing the subtraction, by adding 40. And remember your rules of integers. Negative 24 plus 40. I have different signs, which means I'm going to actually subtract them, okay, which gives me 16. And since 40 has the bigger absolute value and it's positive, 16 is going to stay positive. Now I need to divide by 1/8 on both sides, which will cancel out these 1/8 and leave me with A equals, and when I multiply fractions, I need to keep the first, change the division to multiplication, and flip the second fraction. So I actually have to think, okay, well, what's 16 times 8? And that is 128 over 1 times 1 is 1, so I can leave that. A equals 128. Let's check it. 1/8 times 128 over 1 minus 40. Does that equal negative 24? Well, I can multiply straight across. 128 over 8 minus 40 equals negative 24. 128 divided by 8 gives me 16. And 16 minus 40 does equal negative 24. So I know A equals 128 is correct. Now looking at this one, I still have multiplication, but I'm multiplying by a negative number, and that's okay. And I have addition. So this means I'm going to have to subtract and then divide. I'm first going to subtract because I'm undoing the order of operations, which leaves me with negative 1/5 R equals 30. Now I'm going to divide by negative 1/5. And that leaves me with R on this side equals, keep it, change it, flip it. And in this case, you can put that negative with the numerator, with the denominator, or at the end because you know that a positive times a negative is going to be a negative. It's up to you. And I would get R equals negative 150 over 1. And I don't need to put that 1 in the denominator. So let's check it. Negative 1/5 times negative 150 over 1 plus 35. That should give me 65. Now, in the last problem, we multiplied straight across and then simplified. This time, let's simplify first, because if there's a factor in the numerator and denominator that's common, I can simplify. 5 divided by 5 is 1, and negative 150 divided by 5 is negative 30. And negative 1 times negative 30 is positive 30 over 1, so I don't need to put it, plus 35. That does give me 65, so I know R does equal negative 150. Now in this problem, we actually do have addition, and this is going to be a little strange. If the constant comes first and it happens to be positive, it's really being added in the equation. And I am multiplying negative 4 here, okay? And this is going to make sense in a minute, because it's best to think of that minus 4h as negative 4 times h, which means I'm going to need to subtract and then divide. What am I going to subtract? I'm going to subtract this 16 on both sides. So I need to do 84 minus 16, and that's going to give me 68 over here and negative 4h here. Now do you see how when I treated that like a negative sign, now this equation is much easier to deal with. I just have to divide both sides now because there's multiplication, so to undo it, I use division, and I'm going to divide both sides by negative 4. And that's going to give me h equals positive divided by negative equals negative 17. So, oopsie. So, let's check it to see if this really does work. 16 minus 4 times negative 17 equals 84. So, I can think of it as 16 minus 4 times negative 17, or plus negative 4 times negative 17. And let's treat 4 like a positive in this case, and I'll show you what we're talking about. So negative 17 times 4 is actually negative 68. So when I am subtracting a negative, I'm going to keep the first, change the addition or subtraction to addition, and then switch the addition or the negative to a positive. So what is 16 plus 68? That's 84. So I know I'm correct. And h equals negative 17. Now in this equation, I have operations in the numerator together, so I'm going to treat that like parentheses. But in either case, I have addition and I have division. But since this addition is in parentheses, I'm going to take care of this division first by multiplying. Then I'll take care of this addition by subtracting. Because remember, if I'm using the order of operations backwards, parentheses, or the groupings will come last. So in this case, I need to multiply both sides by 3, which gives me, when these cancel out, 4 plus x equals 30. Now I take care of this 4. And look, this 4 isn't being added or subtracted, but since it comes first and it's positive, I'm going to subtract that 4 from both sides, which leaves me with x equals, oops, not 28, 26. Now let's check our work. 4 plus 26 over 3, we have to see if that equals 10. Now, since I'm using the order of operations in the correct order, I'm going to take care of this numerator first. And 4 plus 26 is 30, divided by 3. That does equal 10, so x equals negative 26. Now it's your turn. In the work section of your WSQ, complete numbers 1 through 4 and show all work, showing each step. You can go back and watch any portion of this video as many times as you need to, or watch the whole thing again. But don't forget to write a question at the bottom of your summary and work.